Welcome back. This is going to be just a quick kind of review of everything we've talked about in the circles chapter. So what we're going to do is we're actually just going to go through each section and kind of just hit the most important part of that section. We are going to start off with the standard equation of a circle. Okay, now that was our standard, and here we have the standard equation. This is the one that we dealt with a whole lot, and we're just going to go through some of the basics again. So the first thing here, H and K are going to be our center. Now, the thing about the center is the value inside the parentheses is actually going to be the opposite sign of the ordered pair. So what that means is if we had a center of a circle of 2, 3, this was our center. If we were going to create the equation, it would actually going to be x minus 2 all squared. It would be y minus 3 all squared. Okay, that's just without the radius part at this point. So again, with the center of the circle, it's always the opposite sign of what's in the equation. Now, the thing for us to remember with the radius is in the equation of a circle, the radius is squared. Okay? It's important for us to remember that it's not just r, it's r squared on the other side. So for example, let's say I had this equation. X plus 3 all squared plus y minus 4 all equal to 25. Well, your job here, of course, would be either to graph this or just label the center a radius. In this case, we just use the same exact process that we just did. We see that it's a positive 3 inside the formula, which means it's a negative 3 for the center. Do the opposite for the y, and we get positive 4. The radius is simply the square root of the other side, giving us 5. That would be the main part of this section. Be able to identify HK and then identify the radius. The next section that we talked about in this chapter dealt with equations of circles starting from the standard form and going into the general, or going from general back into standard. What that means. In this case, we have our standard form and we have our general form. In the standard form, of course, that helps us graph. The general form is really not that useful. But what we saw here was that we needed to use completing the square. We'll kind of go through one of those examples here pretty quickly. We'll just start off with, let's go with this right here. So in this case, it's x squared plus y squared minus 2x minus 4y plus 1 equals 0. Your first objective, get all the x's next to each other, all the y's next to each other, and move the constant to the other side. Now we did this slower in class, but since this is a review, we're going to go through a few steps in one. So the x squared minus 2x, we can move together. We have the y squared and the minus 4y. And that's all equal to negative 1. Now again, that includes a lot of different steps. We just smashed it all into one here. Move the x's next to each other, move the y's next to each other. Move that constant over. The next thing we need to do is pretend like we have two different problems here. Completing the square. And this completing the square process is done by taking b over 2 and squaring it. Remember, in completing the square, we need to be able to take an equation, turn it into a perfect square trinomial. We do this by taking half of b and squaring it. So, are we going to add here? Well, let's take half of negative 2 and square that. Well, half of negative 2 is negative 1. Square that to get positive 1. Okay? But of course, we have to add that to the other side of the equation. We do the same thing for the y's now. So it's still plus y squared minus 4y. But now I have to take half of negative 4 and square it. So half of negative 4 is negative 2. Negative 2 squared is positive 4. But of course, I have to add that to both sides. Negative 1 plus 4 simplifies to just 4. So again, I know this is a lot quicker than what we did in class, but now that we know completing the square a little bit better, we can kind of go a little bit quicker in this process. Our last step here is simply to just go in and rewrite our equation. On the left side, it's going to end up being x minus 1 all squared plus y minus 2 all squared equals 4. We get that negative 1 and the negative 2, so the negative 1 and the negative 2, by simply taking half of b. That was a little shortcut we learned as we went through this process, but we can easily come up with the equation of the circle like so. So that was section 2, and what we learned there was essentially just completing the square and knowing how to go from the general form to the standard. And that's, again, what we did here. The next thing that we went through in the chapter was arcs and angle measurements. And what we needed to do here was go through the different types. And here we're just going to hit pretty quickly all the different properties yet again. Remember that a central angle is the same as the arc measurement. So if your central angle, in this case, if I called it 20 degrees, then so is the arc measurement. Central angle's not that difficult for us to remember that, but it is a very useful tip. Inscribed angles. The inscribed angle is half of the arc measurement. So again, if I were to say that this is 20, well, that means the arc is twice its size, so it would be 40. Inscribed angles, another big thing that the air test is going to go over, but it is a little bit different than just central angle. Here we have exterior angles. And we kind of just went through one or two examples of this in class, but essentially you just take the larger arc, subtract the smaller arc, and divide by 2. So if this was 120, this was 50, we would simply take the large arc minus the small over 2. 70 over 2, which is 35. Now I know that's not to scale, that's just kind of just throwing out numbers here to explain the process of solving. The last type of angle that we really talked about was circumscribed. And a circumscribed angle is really just an exterior angle that has one more special fact about it. Because if you wanted to, you could find this arc and subtract this one, and then divide by 2. But we also learned that the central angle that's formed along with this, I'll try to draw it as best as I can, is going to be supplementary. Meaning if the circumscribed is 20, the central would have to be 160. Adds up to 180 degrees. And that's what this section all dealt with. Okay? So what we're going to do is continue on into arc length. So now that we've seen all the different types of arc measurements, let's go back into arc length and sectors, because they're essentially the same thing. Or they're not the same thing, but they're using the same process to solve. Arc length sets up a proportion from the arc measurement to its circumference. Okay? So, this was our little formula, and it's the same type of formula for sector size. We're going to see just one example, pretty quick, about how to solve a problem like this. In this case, we're just going to set it up so we can go into the sectors and tangents for this video as well. In this case, we would take the measurement out of 360, like so, and set it equal to x, which is the arc length, over the circumference. Circumference is 2 pi times r, radius is 12 in this case, and you would go through and cross multiply to solve. Now, because we are running low on time, I'm just going to go directly to sectors now. And as I said before, it's the same process. But instead of us figuring out the arc length, we're now actually figuring out the entire area. And that's why we have a picture like this, where it's shaded in, telling me that that's the size of the pizza I'm taking. We set it up the same way. Take the arc measure out of 360. I want to figure out the sector size, but now, instead of circumference on the bottom, I'm dealing with area, which is pi times r squared, which is 14 squared. Go through, cross multiply yet again, and you can solve. The last thing we talked about were tangents. So really quickly, tangents. Those are the lines that touch a circle at one point only. And what we know about this is that it's going to be a 90-degree angle with the radius. What we also learned was that when we have our two tangents intersecting on the outside of the circle like this, they're actually going to be congruent. Meaning, if I said this angle, or not angle, this side was 2x plus 3, and this side down here was 3x plus 5, you could set those two equations equal to one another and solve. So, hopefully this video helps clarify anything that you need for the test tomorrow. And again, just review this, look in the foldable, look at Math Excel, those types of things, and it should help you prepare.